going to go through some of the things that can go wrong with trigonometry. This isn't about whether you know how to use the rules or not. If you don't know how to use the rules, then go back and watch those videos. If you don't know what rule to use, then go back and work through the trig basics and then the examples. This is about students who are doing the working, think that they've got it right, but somehow their answer comes out wrong despite having that correct working. So these are the things that often happen. First up, your calculator might not be set in degrees. So how do we check? We type in cos 90 and we get 0. If you're not getting that, then your calculator is not set in degrees and you're never going to get the right answer in that case. So different types of calculators. For the graphics calculator, we go to the run menu, then we go shift setup, and we can see that the angle here is in radians. So when I go cos 90, I don't get 0. Shift setup, I scroll down, I put it in degrees, enter, and now when I go cos 90, I get 0 because it's set up right. If you don't have a graphics calculator, then you still go into setup and enter the number that puts it into degrees. You'll know that's right quite apart from getting cos 90 equals 0, because you will get a very small d at the top of your screen, not a G or an R. Okay, assuming your calculator is set in degrees, then the next most likely reason for getting things wrong is incorrectly bracketing the sine and cos. The old calculators don't need the sine or cos surrounded by brackets. They will just take the next number and assume that it is in brackets. That's usually not a problem. But the newer scientifics will put a bracket at the start of the sin cos automatically, and you need to put the end one in immediately or you get a wrong answer. You'll either get the wrong numerical answer or you'll get a syntax error. So for example, if I have sin of 22 degrees, I have the open bracket, and I don't close the bracket after the 22, then that will interpret that as sine of 22 times 4 is sine of 88 degrees, and you'll get the wrong answer. If you're doing it as a division over sin and you don't put the end bracket, then you get syntax error. So when you have the new calculators, you have to get in a habit of putting brackets immediately after the sin or cos every time. Next up, issues with fractions, usually with the fraction button. The problem is that calculators do different mathematics rules for fractions and for division. So if you type these in your calculators, you will often get different answers. That's because a lot of calculators will read the 22 over 32 as inside the sign, whereas they will read division the other way around. My solution is you try to find that you use division all the time and that you bracket all the time. Because if you bracket sin 22 over 32, then you'll get the right answer. Doesn't matter that you don't need to, just do it all the time and then you don't get it wrong. Next issue with fractions is denominators. Students forget that the calculator does best maths properly, and they forget to bracket the bottoms of fractions. Not a problem with the modern calculators that do the actual fractions, because you can see what's happening. It's more a problem with the graphics. If you have to type this in, then you need to bracket all of the top divided by all of the bottom, or you'll get a nonsense answer. If you type it in like this, then only the 44 divided by 2 is part of the fraction. So those people with non-new scientifics, you need to bracket the whole top divided by the whole bottom. Some students actually just work out what the calculator works out for the top and for the bottom, and then does the fraction as a final stage. If your answers are mostly right but just ever so slightly wrong, then what you've probably done is you haven't put enough decimal places in your answers and through your working all the way through. This is particularly important with inverse sine and cos because they are very, very sensitive to the scale of the answer put in. For example, if we have this inverse sine, 98765, but you cut the answer down very short, either you round it to 0.99, you notice this is out by almost a whole degree. Whereas if you, even worse, chopped it at 0.98, it's out by a degree and a half. Very, very important that you carry all the decimal places through in your working, because your answers are otherwise a long way out. Best way to do this isn't actually to keep typing it all out, it's to use the answer function in your calculator. And don't round until you get to write it at the end. Show all your working all the way through and round only for the final answer. Lastly, it's not quite a calculator thing, this is one of the problems that people sometimes have. They assume symmetry in an object that isn't there. You often have to add lines in a polygon to make triangles, and students will take a quadrilateral, put a line across it, then assume that these two angles are equal and halve them, but they are not. That is not symmetrical. The angles are not equal.